Introduction. Today, we are going to demonstrate procedures on manufacturing high-quality bricks. We will start with the indicators on a cement bag so that we understand what they represent. Thereafter, we will consider the different types of cement produced by OHORONGO cement and their applications. Then we will consider health and safety aspects to keep in mind during the production of bricks. After that, we will briefly look at the ingredients and quantities required to manufacture bricks and discuss each one on their own. We will then briefly cover the steps of the actual brickmaking process. Thereafter, we will discuss quality control and curing of bricks. Cement indicators. Cement indicators, the description of the different cement types, is made up of different sections. Let's look at CEM2 ALL 42.5N as an example. CEM represents ordinary cement produced from clinker. The 2 represents composite cement, which means it contains other extenders additional to only clinker. The ALL is a description of the additives in the cement. The A represents the percentage of additives used in the cement. The LL in this case represents high-grade limestone with a low organic content. The 42.5 represents the minimum compressive strength the cement will achieve after 28 days. This strength class is limited to a maximum compressive strength of 62.5 MPa. The N refers to the normal strength of the cement. Please note that the indicators refer to the cement itself only and not to the strength of the concrete mixture. Cement types. OHORONGO cement currently produces 5 different types of cement. CEM1 52.5N, CEM1 42.5R, CEM2 ALL 42.5N, CEM2 BV 42.5N, and CEM2 BLL 32.5N. CEM1 52.5N is used only for special projects where high strength is required. It can also be blended with extenders, for example fly ash or slagment. CEM1 42.5R is mainly used by industrial brickmakers for its high early strength, but could also be used for blending as it is a pure Portland cement. CEM2 ALL 42.5N is used by ready-mix contractors or batching plants because you can achieve a higher range of concrete strength. CEM2 BV 42.5N is ideal to use at coastal areas due to its properties of high resistance against moisture penetration and chloride-enriched environments. CEM2 BLL 32.5N is used by smaller construction companies and common applications around the house, like plastering and small renovations. Health and safety. In order to protect yourself, you would require the following safety gear. Safety glasses to prevent dust and small objects from harming your eyes. Dust masks to prevent dust from entering your lungs. Take note, cement does not cause illness or disease. However, it will cause throat irritation and dryness. Protective clothing and gloves to prevent skin irritations, as the high amounts of lime can dry out your skin. Safety shoes to protect your feet at all times. You also need to know how to properly handle heavy objects like cement bags. When lifting a bag of cement, you should bend your knees and have a straight back. The alternative is to obtain assistance from another person to handle the bags. Components and equipment required for the manufacturing of concrete bricks. The manufacturing of bricks has three main components: OHORONGO cement, water and sand. You would also require the following equipment: a sieve, at least 2 shovels, at least 2 wheelbarrows, 3 builder's buckets, all of the same size. You also require a wooden pounder or similar object to scrape off excess material. You require a hard surface to mix the mortar. For example, you can use a shutterboard. Then you require an additional hard and even surface where you're going to mold the bricks. This area preferably needs to be in the shade. If not, you would be required to cover your bricks for the first day. You require plastic sheeting to place below the bricks you are going to manufacture. This is not a requirement, but it is advisable. Last but not least, you require a brick mold. When mixed, OHORONGO cement and water together acts as the glue component of the mixture. Note that the water used must be drinkable water fit for human consumption. Sand increases the volume of the mixture, making the bricks more affordable. River sand would be preferable due to its low clay content. Sand should not contain any foreign objects, for example roots, sticks, leaves or animal dung. This could be prevented by sieving the sand prior to use. Also, it's not advisable to use the first half meter of topsoil when obtaining the sand. In order to be sure whether the sand is suitable to use, you can do the following test. Take a small, clear 500 ml bottle and fill it halfway with the sand you want to use. Add clean water to the bottle until it's almost full. Close the lid and shake it well. Let the bottle stand for about an hour for it to settle down until the water at the top is clear. If you do not see a clear separation between the layers of the sand, shake the bottle again and let it stand for another hour. The water should be clear and without roots or other particles. The material at the bottom of the bottle should be coarse, with a small layer of finer particles at the top of it. When the top layer of the material at the bottom of the bottle contains a lot of fines and only a little bit of coarser particles at the bottom, it means that the soil contains too much clay, which would result in weak bricks. This test is only an indication, and sand can be tested in a laboratory for more accurate results. Quantities of components for the manufacturing of bricks. Take 1 bucket of OHORONGO cement CEM2 ALL 42.5N. Note that the sand and water required would differ from region to region. These are good indicators, however, trial and error would be best. In order to find the best mix, you would have to make at least 2 mixes to assess the final outcome. Today, we will start with 5 buckets of sand to 1 bucket of cement and add water as required. For the second mix, you can use 4 buckets of sand to 1 bucket of cement and add water as required. How to manufacture the bricks. Fill the buckets with sand and strike them off evenly with your wooden pounder to level off the surface. Place the sand on the mixing surface or on shutterboard. After all 4 or 5 buckets have been placed on the shutterboard, make a hole in the middle of the heap of sand. Pour the bucket of OHORONGO cement into the hole in the middle of the heap of sand. Mix from the outside inwards and as you move around the material in a circular fashion. Keep on mixing the sand and the OHORONGO cement until you have a uniform color and make a heap. Take half a bucket of water. Make a hole in the middle of the mixed material and carefully pour half a bucket of water into the hole and start mixing it. Move around the material in a circular fashion to ensure proper mixing. In order to determine if you need to add additional water, take a handful of the mortar mixture in your hand, squeeze it and release. If it breaks in your hand, you need to add additional water. If it remains compacted in your hand, the mixture is good. If it remains compacted but you have a smudgy, wet surface, you have too much water in the mix. Always add water in small amounts at a time to prevent adding too much. Place the concrete mixture in a wheelbarrow and take it to the second area where you are going to mold the bricks. If you have plastic sheeting, place it on the even surface where you're going to mold the bricks. Place the brick mold on top of the plastic sheeting or the shutterboard at the place where you want to mold your first bricks. Remove the top section of the brick mold so that you can fill the bottom part with the concrete mixture. Keep in consideration that the bricks need to remain in this space until the next day before they can be moved. Fill the bottom part of the mold with the mortar mixture and strike off the excess mixture with a wooden pounder. Note that you should not compact the mixture yet with the pounder. Remove all excess mixture around the mold and put it into the wheelbarrow to be mixed back. Take the top part of the mold and place it carefully over the bottom part. First, utilize body weight by putting pressure onto the mold and push down hard. Make sure that you are directly above the mold so as to ensure an even surfaced brick. Neglecting to do this will result in a skew brick. Now, use short bursts of compaction movements with the top part of the mold to properly compact the bricks. Again, ensure you do this directly above the mold. Do this for about 5 seconds. Now, step onto the sides of the mold to keep the top section of the mold in place with your body weight. Carefully, in an upright manner, place your hands on the handles of the bottom section of the mold and pull the mold upwards until the two handles of the two parts of the molds are aligned. Remove the entire mold all at once to reveal the bricks. Maximize surface space by placing demolded bricks not too far apart when demolding bricks. Continue this process of molding until you have used the entire concrete mixtures. After each batch, the mold should be washed with water. Clean up. Once you have completed the molding of the bricks, make sure that your mold is washed properly in the plastic container filled with water to dispose of any signs of concrete mixture. Also, wash all your other tools to get rid of any signs of the concrete mixture. Should you want to, you could use mold oil, available at any hardware store, to oil the brick mold. The purpose of this is to make demolding easier. Please do not utilize old motor vehicle oil. It will color the bricks and reduce bonding between bricks and mortar when you build a wall. If you want to, you can also oil the rest of your tools. Curing of bricks. On the following day, bricks can be carried to a storage area where they can be stacked on top of one another. Do not stack higher than 1.5 meters on top of one another. Bricks must be sprayed with water for 6 consecutive days, 3 times a day. This process is called curing. Testing brick strength. Take 2 7-day-old bricks and knock the 2 bricks together against one another. When the sound is higher pitched, like a ringing sound, it means the bricks are strong, and they should not break in half or the corners will not break off. When you hear a dull sound, the brick is weak and will most probably break in half or corners will break off when you hit it against one another. This is only an indication, and bricks can be tested in a laboratory for more accurate results. You can also consult our OHORONGO Cement website at www.ohorongo/cement.com for more information on brickmaking, or contact us directly. Congratulations on using OHORONGO Cement for bricks that are OHORONGO strong and will last for generations to come. OHORONGO Cement, cementing trust, building futures.